And now one last thing I'm going to add to the class is, well, we're going to solve a very common problem with push button, and this common problem is actually the bounce problem. So I'm not going to go with all the details in the world about the bounce problem, okay? I suppose that you already are familiar, a little bit familiar with this because you take this intermediate course. But basically the thing is that the push button, so the hardware push button, can bounce. So when you actually press on the button, or when you release the button, the state of the button can bounce a few times between high and low in a short period of time, but this may give you incorrect results when you want to get the state of the button very fast. So what we can do is we can debounce the button in the software directly. And that's what I'm going to do. I'm going to add the debounce functionality for the push button. And the great news about this is we are not going to change anything in the main code, okay? And we are not going to change anything in the public part of the interface. We are only going to add some private attributes and add a bit of logic in the implementation so that for the user that uses the push button class, it will be completely transparent. Okay, the user will not have to worry about anything about the debounce functionality. So that's great, okay? We can completely hide the functionality and make it work correctly. So first thing, I'm going to add two private attributes here. Let's put that here like this. So unsigned long last time state changed and unsigned long debounce delay. So to debounce the button, we need to keep track of when actually the state of the pin changed for the last time. So I create last time states changed. And we also need, of course, to get a debounce delay, okay, to say that, for example, after the state has changed, we want to ignore the following state for, let's say, 50 milliseconds, so that we ignore all the bounces of the button. So now that we have this, let's go to the constructor here of the class, and I'm going to do, so we have last time state changed. I'm going to initialize that to millis, and then I'm going to do debounce delay. I'm going to initialize that to, let's say we want 50 milliseconds. Okay, so the constructor, as you can see, is a good place to initialize your variables or your class attributes. So if you get some attributes directly from the parameters, then you use this with the name of the attribute and the name of the parameter. Okay, with this, of course, if it's the same name, to avoid confusion. And for any parameter that you don't get here, we don't get the last time state changed and the debounce delay from the parameters. So you just put the name of the attribute like this, and you just initialize them with the value that you want. If you want here, for example, you could also use a constant somewhere, okay, to not hard code this in the code, but here it's quite fine, okay, we just put the value inside the constructor. So now what do we need to do to debounce the button? Well, when we init the button, we don't need to do anything, okay? When we is priced here, we don't need to do anything. What we're going to do is to modify the read state method here. Okay, so let's implement the debounce functionality in the read state. So I'm going to go again a little bit quite fast because the debounce functionality is something a little bit outside of the topic of this course. So to debounce the button, first I need, when I read the state, I need to get the current time. So unsigned long time now is equal to millis. So I get the current time with millis. Okay, I use millis and I use millis here. If you want to use micros, make sure you use micros for everything, okay? And millis here for everything. Don't mix those. And then I'm going to do if time now minus the last time the state changed. So here, if this is greater than the debounce delay, then we're going to read the state. And actually, I'm not going to put directly the value of the pin here in the state attribute. I'm going to create byte new state is equal to digital read from the pin. And then check if new state is different from state. So state here, we are using the attribute from the class. In that case, I do two things. I do state is equal to new state, and last time state changed is equal to time now. And let me explain what I did here. So when we enter the read state function, first we are going to check the difference of time between the current time and the last time the button state has changed. Okay, if this is greater than the debounce delay, so here 50 milliseconds, then we can read the state. Okay, so if the state doesn't change, then this is always going to be true. Okay, and so we read the state, we don't store it directly, okay, in the class. We create a new intermediate variable here. And then we check if the state has changed. Okay, if the state hasn't changed, then it's not useful to store a new state. Okay, if it was high and it's still high, then well, no need to store the new state, it's already high. But if it's different, then we actually update the state. Okay, so if it was high and now it's low, then we put the state to low. And we, of course, also update the last time the state has changed to the time now. So it means that you are going to keep reading this. If you read very fast, it's going to read this very fast. Let's say the state is high, so it's continue to be high. And then when the state changes, you are going to enter this if, so update the state attribute, update also the last time state change attribute. And the next time you enter the read state, if you enter it before 50 milliseconds has passed, you are not going to read the state of the button. So with this mechanism, you can ensure that the debounce functionality is correctly implemented. And the best part is you don't even need to worry about this in, for example, in that function. And you don't need to worry about this outside of the class. Okay. One thing I'm still going to do here when I init, instead of doing a read state, because if I init just after I create the class, the problem is that this if is probably going to be false. So instead of read state, just in the init, I'm going to do state is equal to digital read pin. For the first time, I just use digital read. Okay, this will be the primary state. And then whenever we call read state, it's going to check the new state and also apply the debounce functionality. And now, well, it seems that our class is complete. So as you can see, I have added two attributes here, but nothing has changed in the public interface. Nothing has changed in the code. I can still verify the code. Okay, and I can still run the code. That's going to be the same behavior.